All right, so for this lesson, we are going to continue to find limits, and I'm going to give you two more procedures. So if you think from the last lesson, we had direct substitution. I don't even know how to substitution. We had canceling. We had factoring. And now we have these two things, which is rationalize and complex fractions. So these are sort of like your steps, and you're going to try and figure out which tool to use in the toolbox. Okay, so immediately we always want to start with direct substitution. So if I plugged in 5 into here, I would get 5 plus 4 minus 3 all over 5 minus 5, which would give me, end up being 0 over 0. So we know that that is not good. So since we can't use direct substitution, we have to do something else. We can't really cancel anything. We can't factor anything. So we're going to rationalize. And this hopefully is a review, but if not, it is a vocab turn. And so to rationalize something, right, to get rid of the rational number, the square root, we have to multiply by 1, right, using the identity property of 1. And we have to do the conjugate. So if you remember difference of squares, you're going to use this trick a lot. So if we have a minus b times a plus b, it ends up being a squared minus ab plus ab minus b squared, and those two cancel, so we just get a squared minus b squared. So this is something that you should like be really used to, like knowing that if you do the conjugate, right, because this is the conjugate, which is another vocab word, then it helps you cancel out things, right? It helps you cancel out these middle terms. And you should be able to go back and forth, right? If I gave you x squared minus 9, then the factors would be x plus 3, x minus 3. All right, so if we go back here, we have to multiply this by the conjugate. So it's going to look really ugly, but it's going to be the square root of x plus 4 plus 3 all over x plus 4 plus 3. We'll just highlight how we found the conjugate. Right, and just in case you forget, we're doing this because this is the identity property of 1. We're allowed to multiply something as long as it's 1. Okay, so to go through this whole thing, it's a lot of algebra, and you have to be really careful with your steps. So let's go down here for the numerator. So the square root of something times itself just becomes that thing without the square root. And then we know that it's the b, like negative 3 times 3. So it's just minus 9. So this is everything on top. And then the bottom is where it gets sort of ugly. We'll just keep it factored. So I just had this in a parentheses and this in a parentheses. Okay, so these are designed to like cancel out. So if you're not finding it's canceling out, then you probably did something wrong algebraically. So if we look here, this on top can be simplified to x minus 5. And then on the bottom we have the same thing. And you'll notice that we can cancel something out. So we cancel these two out. And then we're just left with 1 over the square root of x plus 4 plus 3. And now, whenever you're doing these, you want to go back and see what we can do, right? So we rationalized, and then we went to canceling, and now let's try direct substitution, right? We're trying to get to the point where we can do direct substitution. So we have to do all these things in like different orders. So here, if I plug in 5, I get 1 over the square root of 5 plus 4 plus 3. And that is 1 over 3 plus 3, or 1 over 6. And I'm going to highlight where this 5 is coming from. Right, so originally we tried to directly substitute. We couldn't because we got 0 over 0. And then we went in and did this rationalizing thing, and we got 1 over 6. So if you plug this into your calculator or you looked at a graph, you would get 1 out of 6, but sometimes they make you do this without a calculator. Alright, so I want you to, with your table, work on number 2 and see if you can figure out number 2. Okay, so for this, we want to get rid of this guy, so our conjugate is 3 plus the square root of x minus 1. So we're going to multiply the top and bottom by 3 plus square root x minus 1. Okay, I'm going to do this the long way through FOIL or box method, and then hopefully you'll be able to see how the difference of squares makes it easier. So this top part we're just going to keep the same in factored form. And then the bottom part we're going to FOIL. So I'm going to write it in factored form and then FOIL. Okay. So we do the first, right? So we have 3 times 3 is 9. And then the outside. So this guy we're just going to keep together as a whole, right? Because it's so messy. So we're going to do plus 3 times the square root of x minus 1. Inside, minus 3 times x, the square root of x minus 1. And then last, minus square root of x minus 1 squared. All right. Does this make sense, this FOIL, what we did on the bottom, the denominator? Even though it's like ugly, even though this like square root of x minus 1, like pretend that this square root of x minus 1 was just like an r, right? We would have 3 times 3 plus 3r minus 3r minus r squared, right? We could use like a dummy variable, but we're just keeping it in its ugly form. But it's still the same process of FOIL. So if we simplify this, we get 9 plus, and then these two are going to cancel out. So whenever you do this, the conjugate, that's the whole point. This like middle term is going to cancel out. And then we're left with minus the square root of x minus 1 squared. So these two things cancel each other out, like taking the square root and squaring it. So you really just get 9 plus negative x minus 1, which is 9 minus x minus 1, which is 9 minus x plus 1, which is x 10 minus x. Right, so this is what this whole thing turns into. So we're going to just put the same on the top. I don't have enough room. I'll just write same. On the bottom we have, let's do negative x plus 10. Right, just rewriting it in the other way. So some of you notice, like, we're trying to get this to cancel, but this is a little different, so we're going to rewrite it. We're going to rewrite it as, we'll do it up here. We're going to pull out a negative 1, and then we get x minus 10. So now this is the same. It cancels. I'm trying to figure out where I could put it. So we have x minus 10, 3 plus square root of x minus 1, all over negative 1 x minus 10. These two things cancel by design, and then we can just plug in 10, and we end up getting negative 6. So we have 3 plus 3 over negative 1, which is negative 6. So just remember to FOIL, but you can skip this step if you remember the difference of squares, but you'll still get the same answer. So make sure you do the practice for these, because a lot of you haven't rationalized in a while, if ever. Okay, so for complex fractions, again, we can try direct substitution first. So if we plug in 0, we get 0 over 1 over 4 plus 1 over 4, which is 0 over 0. Sorry, negative. So we can do direct substitution, so we have to do something different. This is already in the complex fractions section, so we're going to do complex fractions. So what we want to do is we want to get a common denominator, right, when we're adding fractions. So this is going to look really ugly, but just stick with it. So we need a common denominator, so we're going to multiply this first one by 4 over 4. And then the second part by the x minus 4. Right, so we try to get our common denominator by matching what was on the other fraction. So this is hopefully a review. Right now we're sort of ignoring the top, like this x up here. We're just focusing on the denominator, trying to get it a little prettier. So let's simplify. So 4 times 1 is 4 all over 4x minus 4 plus x minus 4 all over that same denominator. So now we have a common denominator and we can just add. So again, we're sort of ignoring the top. 4 plus x minus 4 just turns into x. And then we have 4x minus 4. So everything looks ugly, but it's really just adding fractions. So the trick to get this all unmessy is to think about dividing fractions, which is a vocab term. So if we have x divided by a fraction, that's the same thing as saying x times the reciprocal. So we're going to flip the one on the bottom. So numerator times reciprocal of denominator. Right? Sort of think of, I'm going to put an example over here. Okay, I'm going to put it down here. Right? Think of like 1 divided by 1/2. Right? Like that's really ugly, but it's really just 1 times 2 over 1. So it's the same thing. It just looks uglier because there's like a lot of x's. So when we're dividing fractions, it's the first one times the reciprocal. And reciprocal is a vocab term too. It means you flip the top and the bottom. So if you notice here, these two are going to cancel out by design. And then we can plug in 0. We can do our direct substitution step. So we do 4, 0 minus 4. So this is negative 16. Okay, let's do the last one. So if we do direct substitution, we get 1 over 9 minus 1 over 9 over 0, which is 0 over 0. So we can't do that. So we're going to make this fraction less ugly. So we need a common denominator. Right, so here we multiply by 9 over 9. Here we multiply by x plus 3 squared over x plus 3 squared. And now we simplify, we multiply. Let's FOIL this out. Multiply it out. X squared plus 6x plus 9. I'm ignoring the bottom right now, right? This x, we're just doing the numerator. So this becomes 9 minus x squared minus 6x minus 9. So remember, it's minus, so this minus will distribute across all of it. And then this simplifies, the 9's cancel, so we get so this, remember, this is the numerator. So we have this whole thing all over x. And so if we think about it, we can divide the top and the bottom by x. And that means taking out an x from the numerator here. So we get negative x minus 6 all over 9x plus 3 squared all over 1, which is just itself. And then we can plug in 0. We can try direct substitution. So we go 0 minus 6 over 9 times 3 squared, which is negative 6 over 81, which is the same thing as negative 2 over 27. So let's see, right? We go from here to there, to there, to there, to there. Right? Not very organized notes, but that is the last example. So make sure you practice these, and I'm going to post the answers.